Good evening, everybody, and welcome to the streaming for the OWASP BeNeLux Days 2020, second day. Today we have on the schedule a panel or seminar by Brooke E. Schoenfield and Isar Tarandach about Agile threat modeling. Other meetings this week are the OWASP Projects Tour with Nicole Berger and Nancy Garici from OWASP Desktop and Grant Angers from OWASP Cornucopia. On the first day, we will have Anastasia Fiatova on maintaining a crypto library for 12 languages and Jeff Foley on OWASP AMAS. Please note that the presentation from Jeff Foley was earlier scheduled for Wednesday but has been moved to the Thursday. If you would like to receive updates on the schedule, please register, and information can be found on owaspbenelux.eu. The presentation itself will start at 7:30. Please stay tuned. Ladies and gentlemen, welcome to the OWASP BeNeLux Days 2020 virtual. We have today a panel with Brooke Schoenfield and Isar on the topic of Agile threat modeling. The host for today will be Sebastian de Leer-Schneider. Sebastian, the floor is yours.
Thank you, Edwin. Thank you for joining on this, I would say, live YouTube channel, and afterwards, if you'll be looking at this, hopefully. So I'm really thrilled to have two of our, I would say, threat modeling heroes in the same call. Isar is going to join in a couple of minutes. He's up next. But we have Brooke Schoenfield, who's going to present first on doing threat modeling and how that fits in a software security development life cycle. And then afterwards, Isar is also going to present on threat modeling for Agile. Now, I know Brooke for his first book that he wrote on securing systems, applied security architecture and threat models, which I highly recommend. I definitely use it a lot in practice and also refer to it in our trainings. And I assume that it will also come back a little bit in your presentation, Brooke. Also, recently, Brooke wrote a new book on secrets of a cybersecurity architect. So it's no secret anymore there. So also highly recommend that one. But enough pitching. I propose that Brooke starts with his presentation. We have Brooke for about half an hour, and then Isar. Isar, you're just joining, just in time. Then Isar will follow up with his talk, and then we'll open the floor for questions and do Q&A and our panel discussion. So, Brooke, the floor is yours.
All right, thank you very much, Sebastian. Let me go into slideshare mode. So you might think Agile, especially if you've experienced some old-fashioned threat modeling, you might experience that as an oxymoron or can threat modeling be Agile? I hope that Isar and I can answer that question definitively by the end of this day, and you'll have a much better sense of it and actually how to approach that. Because everybody's talking about threat modeling right now. Now, maybe not everybody, but a lot of people. Right at this moment, for the last year or two, threat modeling has become maybe even a little bit fashionable. People talk about it, but do we actually know what it means? Is that something you're really solid in? That you really think you know what it means? I find people sometimes come to me and say, threat modeling is a data flow diagram. Well, a data flow diagram might be very useful, but that's not threat modeling. That's an artifact we might use, or it's stride. And we're not going to talk about stride much today, but if it works for you, great, fantastic. And why is it important? Why should we be threat modeling? I mean, is it just a fashion statement, or is there a reason to do it? I hope I can answer these questions today. And finally, I had a CTO that I worked for at one of my posts, one of my roles, who literally said to us, "Why do I have to pay for this product security stuff? I already pay for static analysis. Doesn't that take care of it?" So I'm going to hopefully answer all of these questions in this presentation and help you climb into Agile threat modeling, if there is such a thing. First, let's define it. Yeah.
Just want to make sure, Brooke, I'm not sure we're seeing your screen. So just to make sure, are you sharing your screen? Because I don't see it.
Oh, I forgot to, thank you. Always a little bump in the road. I apologize to everyone for that.
No
really
problem.
sloppy.
The introduction was clear.
Yeah, no, we had this all worked out. We had this all worked out. Let me go from this slide, and I'll go to the next one. I said I would define threat modeling, and this comes out of some work that Isar and I have been doing for about 4 months, 5 months. Yeah, Isar? This definition is the definition we arrived at on the Threat Modeling Manifesto, which is go up there, use it. I'm going to refer to it a bunch today because it was just released last about 8 days ago. And so, it's getting out there, and I hope it helps. But this is as good a definition, I think, as any. Threat modeling is analyzing representations, not the system. That would be penetration testing or some other kind of verification step or validation step. It's analyzing representations of a system. And we're going to find out why that's important in a minute. To highlight concerns about security and privacy characteristics. So we haven't said here to improve the security because maybe you don't want to do that. Maybe that's a decision you've made. We really want to think about the security and privacy of a system. And system here is inclusive because there just isn't a better term. And I've used that term now for about 7 years or so, 8 years. And I just can't think of a more inclusive. Your organization, a piece of software, an integration, whatever you're threat modeling. And it doesn't have to be limited to high-tech threat modeling, by the way. So I threw some stuff on this slide that I just want to make you aware of. There's the Threat Modeling Manifesto. Absolutely, go to the application threat modeling resources at OWASP. Go there. These are really, really deep, especially if you're in the web world. But even if you're not, at least they'll tell you give you some ideas about what it is and how it works. There's this safe code thing that Isar and I helped write. Yes, I'm picking on you, Isar. We're co-authors of this thing. It's, threat modeling basically, in a tiny little booklet. And we also did this thing, if you want to know more about secure design, but Isar and I are among the 14 authors of this IEEE book. These are all free to a good home. So get out there and grab these things. Our friend and practitioner, fellow practitioner, Adam Shostak, always asks, what are we working on? What can go wrong? What are we going to do about it? And did we do a good enough job? And that really sums up threat modeling, I think, in a really simple and direct and brief way. But let me put some flesh on these bones, if you don't mind. Or tofu in your sandwich, depending upon your predilections, however you think about these things. Really, in a nutshell, you think about those attacks we know about. So you don't have to make up stuff, really. You think about those attacks we know about that have been successful in architectures, systems, technologies that you're using or that are similar, because of course attackers are creative and adaptive, and so you got to remember that. And so really we have the catalog of attacks. It's pretty easy to find out, and we got some resources. You can ask us later about where you can find some of this stuff, but you don't have to make up things, and you apply those attacks. You think about, could this attack be leveled against those places on the system that attackers might reach? We call those attack surfaces. That's an actual formal term. So, if you want to know what it is, but you think about, okay, this interface is exposed to the internet, it's going to get banged. Even if I throw authentication on here, attackers will still bang at the stack beneath the authentication, and they'll bang at the authentication. We know that, 100% sure. Whether they'll be successful is another problem, but we know, and we know what attacks they are going to likely use because we know which ones are weaponized and what have been used a lot. So we can think about that pretty carefully. And then we gauge the negative impacts. You kind of think, okay, if the attacker's successful, what more can they get, or how can they misuse things? And that's where, it's all about the data comes around. Then we rate the risk for each attack scenario. That's very important because we got to know what the right defenses are, because probably you don't have enough money. I never do, to build everything. ever. I've never been unconstrained. So I got to know what's important and what can be left on the floor. And we use risk for that. So this is threat modeling in a nutshell. We're not going to go any deeper than this. If you want to ask questions in the panel, please do. I threw some other slides in here. You know, I teach this all the time. So does Isar. So, you know, we can go much deeper. I'm not going to go any deeper than this. But in a nutshell, it's attacks to attack surfaces, figure out what can go wrong, and then, you know, figure out what you're going to do about it. All right. So why is this important? Well, it's what we do to anticipate attacks before they occur, hopefully. That's why we threat model. So it's part and parcel of design. It's an aspect of design, just like performance or scalability. It's not some special thing that happens from the specialist security person, although, you know, having someone who knows a lot about attacks and defenses is useful, don't get me wrong. But nevertheless, it's not some special thing. It's just an aspect of design. In today's world where attacks, where at least attempted attacks in certain environments are given, we have to think about security as we figure out what we're going to implement. And however you figure out how you're going to implement and what you're going to implement, you should include iterative. And I put that in parentheses because we're going to dig into that. That's the heart of Agile threat modeling, iterative threat modeling. And here's a little quote from the Threat Modeling Manifesto on the bottom, just to be clear. It allows you to pinpoint design and implementation issues that require mitigation. That's the essence here. That's why we do it, because there really isn't a better way when we're figuring out what we're going to implement to figure out what security we need or privacy we need to put into something. We use threat modeling for that. So are there Agile methods? You bet there are. This is not an Agile method. Used to be, and I'm guilty of this as much as anybody who's been around for 20 years. When we first started threat modeling, we didn't call it threat modeling. There's a dustbin of history of architecture, risk review, architecture, security, architecture review, a million different names, not a million, but a lot of different names that we've used. It's all threat modeling, I've come to believe. And so, you know, where you had a central team and they jumped into a project, who knows at what timing, whatever was convenient to the, you know, the experts. A couple of experts went off with the security person. The security person's job was to find as many flaws as possible. That's Gary McGraw's term. I hate it because it, you know, if I were a developer on the side of I found a bunch of flaws in your design, how does that feel? It feels really horrid. So I don't use that term actually, but you know, Gary McGraw, that was the old way. We want to find what's wrong. This is wrong. You did this wrong. And then you generate a bunch of requirements which cannot be changed no matter what happens. And then you go on to the next threat model and the next project. And that was my life for many years, to be honest. And you caught the problems just before release, which is a little late if you're thinking about that. And so, you know, your Agile teams would come, and this would happen all the time. They'd say, I'm sorry, everything changed as we learned about what we were building, and your requirements couldn't change, so we didn't build them. And what does that lead to? You know, it's not effective. It's awful. So it's taught me that software security cannot be imposed. It cannot. It's earned through the, you know, driven and coordinated efforts of a lot of people. And we tried to get that into the threat modeling manifesto with this little quote on the bottom: assemble a diverse team with appropriate subject matter experts and cross-functional collaboration. This quote here that you're reading, if you're reading it, bothering to read it, is from my next book that I wrote with James Ransom, Building Insecurity at Agile Speed. So you're probably getting the drift that I think threat modeling and security can be done in Agile just fine. And actually, we've done it for years. So, now I'm exposing my actual opinion here. And it matters. The context of how we do this really matters. So the first thing I'm going to say is, in your organizations, have you bothered to define secure software? Remarkably stable for the last 20 years. If I say software security, many people, unless they're practitioners, will think of one of these things. They will think of encryption, maybe TLS or HTTPS if you work in the web world, or hard disk encryption or server encryption or database encryption. They'll think of encryption, which is a solution, not a design, right? It's something we do when we've decided we need to do it. Or they'll think of authentication and authorization, which also are a solution. Or they'll think of just coding errors, secure coding, and the tests we use to help those. Those have been remarkably stable for 20 years, which is something to think about. I personally have put into my last 3 books, actually my last 4 books, a series of attributes, but you could also use Schrader's, which was published in 1976, I think, or that little book that Isar and I worked on, however. But I'm going to suggest that if you don't know what you're designing to, how are you going to design to it? So it's important for you to figure out, for your organization, for your development, what does secure software mean to us? And so that you can drive yourself toward it. I cannot design personally without knowing what I'm designing for and where I'm going. So that's my first suggestion. That's first piece to the context. Second, are there constraints? So let me open that up a little bit. For those folks who are writing mostly features and twiddles to a set architecture in a couple of languages, to a set of infrastructure and a set of support utilities and libraries and whatnot, you might be able to get away with a very document, a threat library, and the usual solutions to that. As much of that you can do, that's great. And that's a situation that's actually pretty simple. And we'll talk about automation in a little bit at the end of this presentation, but that's a rife for automation, in my opinion. If, on the other hand, where I've had portfolios where we had everything from thunks underneath the operating system or hooking the bootloader to major global clouds, by the time you wrote those threat libraries, all of that would have changed. So it wasn't worth doing that. That's a situation where you're going to have trouble getting everything said, and you're going to need a lot of human analysis, or at least some human analysis. So that's another piece of the context that you want to think about. And do you have the expertise that you need? Because, as I said, this goes a lot faster when you have someone who has studied the attacks and the relevant attacks and the relevant defenses that will work in your environment. So that's kind of what a security architect usually brings to the table. So the first thing is you got to know, how is software developed? This is a big problem I see a lot out there, is that the threat modeling or the secure design activities aren't aligned well with how development is actually working. So in this talk, we're assuming Agile because we put Agile on the front, and that's what this is all about. But are you doing DevOps? Because that collapses things in interesting ways. The philosophy of that collapses things. Do you have a CI/CD, that is a continuous integration and continuous delivery pipeline? Or are you doing releases? This matters. How is your build and deploy? Is it really large? Do you have epics? Because a lot of the structure will be defined in those epics, typically. And so you have to hook the epics as opposed to just waiting for the Scrum team in the backlog. So these things are all things to consider. And I threw modified Agile up here because that does exist and people do talk about that. Whether, I'm not going to argue whether that's really agile or not. I'm not interested in that conversation. But if you're doing modified agile, in what way? And how does that change the way you develop software? It comes down to who designs and when. And I got a couple of examples for you here. Because threat modeling must align with an organization's development practices. This is, again, the threat modeling manifesto. You got to integrate organically or naturally, or developers, and if there are developers in the room, hopefully they're all virtually nodding their head, won't like it, and it will get in the way. When you integrate organically and naturally, it becomes part of what we do. And I've seen this. I know it is possible. This is not theoretical. This is from the field. And Isar is going to show you some real field tested stuff in his talk. So if design occurs as part of an implementation, and you see this a lot in startups, and you also see it a lot where people are building proof of concepts or the first or second minimal viable product, MVP, you see this a lot, where design is occurring as part of the implementation. Then the threat model unfolds with the implementation. It's just part of how you think about what you're going to implement and what you're learning. And so the threat model has to breathe, well, period, the threat model has to breathe with change, because change is part of development. So if design occurs before implementation, which is kind of a classic situation, that's classic. You read about it all in the software development books, but doesn't necessarily occur. And really, these are up to the team in a lot of agile shops, and should be, in my opinion, how they best want to take their work. And so where design occurs before implementation, as I said, the threat model is just a key contributor to design. After design is complete, or worse, after the software is complete, at the very least, you're getting rework and exceptions and risk waivers and executive sign-offs. So who needs that? I mean, exceptions can be a great tool, but still, who needs that? It's one of the, as a security person, it's one of the most dispiriting things that can happen, disempowering. Somebody calls you and say, we're going live tomorrow. Can you bless our security? There's almost nothing you can do. It's very dispiriting. So I want to talk about DevOps a little bit. On the left on my screen, you're going to see Redmine's infinite loop of DevOps. And that's often, people parcel out what you do in different ways. And then, this is not canonical in any way. But people parcel this out, but I don't like this infinite loop, and I'll tell you why. It's still linear. It still says I'm planning before I create, and that ain't the way it works. It really isn't. So in my terrible graphic skills, dreadful graphic skills, I did the thing on the right. It's really a bunch of infinite loops, and they're held together around a hub of our goals and lots of feedback and communication between various activities. And so, despite the fact that my drawing is probably dreadful, and it is, we did put it in the book because we don't have a better drawing to do this, this next book that's coming out. Still, hopefully it gives you an idea. It's a bunch of interdependent infinite loops. DevOps, it's a bunch of independent infinite loops, and it's continuous activity, maybe not constantly continuous, and maybe some of the people go over to other activities, but really it's pretty continuous, and we're held together by this idea that we're actually all talking and sharing on the same stuff and working on it. And threat modeling in this situation works kind of like this. I know my little drawing of a iteration, the little arrows on the top are really ugly, but hopefully they give you some idea. Really, in threat modeling, we're really concerned about planning, creating, and verifying. And we're touching the threat model constantly, not constantly, but regularly, repeatedly, to refine and review and change. And then the monitoring, especially in cloud type situations, in DevOps, we're really monitoring, especially where you have so much code going on, where everybody's coder. The monitoring, it feeds back into our plan, which feeds into our threat model, and it feeds back into our, what are we verifying, and are we verifying it correctly? So there's all this feedback that comes from the running that influences our future threat model and helps refine it. There's a big tie between verifications and monitoring and threat modeling, because you prove your threat model by what happens in the real world, whether you did it right or not. So really, it's continuous refinement, not, repeating, iterative. And as we said in the Threat Modeling Manifesto, a journey of understanding over a security or privacy snapshot. Okay, so finally, what about threat modeling automation? I did say I would cover this. There's been a lot of movement in this. When I wrote Securing Systems, there was one threat modeling tool. My friend Archie Agrawal had thrown it out there. He and I were part of the SANS GWeb certification board. We worked on the GWeb certification for SANS. And so he and I met, and he said, take a look at this thing I got in beta. And I said, wow, this is the first tool that actually thinks like an architect thinks. This is the very first tool. So I put a little postscript in Securing Systems about that, thinking this is an interesting development, and we'll see how this plays out. Well, now we're 6, 7 years, almost 7 years on, and there are 2 really good commercial tools and a spate of other tools that can be useful. And so I really think the market has matured. Both of those tools do some things very similarly, which is to me a mark of a maturing market. When a tool starts from a different direction and has to put in some stuff that the other guy has, that's a really good sign. And so I think the tools have matured a lot. I have no favorites. Both the people who run both of those companies are dear friends of mine, and I love their work. And so you're not going to get a favorite out of me ever. But there's a spate of other tools too. I think there's a new entrant, which I haven't had a chance to look at just the last few weeks. There's a bunch of open source projects. And Isar maybe will mention the one that he started. He had me look at it, and I did comment on it, didn't I, Isar? I always do. And I think it's very powerful and very interesting. There's a bunch of spate of open source things that you can contribute to and use. And OWASP has theirs. But there's also other tools. At the very least, you might be able to get a tool that just looks like if you did your architecture diagrams in UML, when they change, you could automatically spin off a TM story, a threat modeling story. All of that stuff is really interesting. So there's a lot of automation. So if anybody tells you that there's no automation in threat modeling, they're wrong. But let me set the how I see and you're free to disagree with me, but I think the automation captures that stuff which is well known, which is great, because the first 5 times I said you need to validate your inputs and escape your inputs to avoid cross-site scripting, I felt really powerful, like I knew what I was talking about. The next 10 times I felt like, wow, I know how to do my job. And the last 1,000 times I've had to say that, it's been really boring. Why do we have to say it? We know that. It should be in a tool. You got a web input. And in fact, you could do what Christoph Kern did at Google and just, write a library that if you don't include and use the library, they break your build. And so they don't have any cross-site scripting problems in that part of Google because they fixed it. Really some of these things, we can automate this stuff. And so if those sorts of things ought to be part of automation, we shouldn't be doing those. I think I want to spend my time on the unique, the complex, those technical debt that are really difficult, that were written for entirely different threat landscapes, and need to be updated. That's the sort of thing I want to spend my time on, because that's stuff that needs human analysis. The rest of it can be automated. So that's my personal hit on automation in threat modeling. Yeah, but you probably can't automate everything. You should probably just, do it. You're going to have to still have some experts and still do some expert, but automate as much as you can. And what we said in the manifesto was support your approach with tools that allow you to increase your productivity, enhance your workflows, and enable repeatability and provide measurability. Yeah. And that's what these tools do, but they're not going to cover it all. You're not going to be able to lick this problem unless you're doing things that are really, really inside the lines we know about how to draw, to color inside some very careful lines. If you're doing anything innovative or complex or whatever, you're probably still going to need to do some threat modeling. So that's my talk for the day. I hope you got something useful. I'm going to turn it over to Isar, who is a very dear friend and one of the greatest practitioners on this planet, I'll just tell you. So you're really lucky to hear him today.
Thank you, Brooke. Thank you for that presentation.
Brooke. Okay.
All right, Isar, you're up next. So first of all, I might like to introduce Isar. So he's very happy also that you agreed to join us on this evening or morning, wherever you are. Isar has recently also, he's already involved in a lot of security stuff, and you can read his bio on the website. But I especially wanted to mention that he has written together with another guy and spent a lot of his time this year a book on threat modeling, a practical guide for development teams, which I highly recommend. So after this talk, have a look at it, download it from Amazon, and enjoy that. With that, I give the floor to Isar and on Agile threat modeling.
Thank you. It's saying that the host disabled participant screen sharing.
All right, then I should make you co-host. There you are.
Okay, can you guys see my screen?
Yes.
Wonderful. Okay, so today, first of all, thank you very much for having me. Such an honor, not only to be here, but to share the space with you guys. Today, I'm going to talk to you about continuous threat modeling and try to put a bit of the taste of one given implementation in all the things that Brooke just brought forward. So, first of all, the joy and dread of speaking after Brooke. So as you guys noticed from his many quotes, we have worked closely together for a long time. And that's one of the things that I really, really, really enjoy the most in the stuff that I get to do. So first, the joy. You just heard for, let's call it 25 minutes, be nice about it, one of the foremost authors and somebody who I define as a master threat modeler. And hear a lot of what he had to say, put it in very succinct ways, and talk to this thing that we all call threat modeling and funnel it down to Agile. That's extremely difficult. Anybody here that's been working for a long time with an intractable problem knows how difficult it is to bring it down, to distill it to something that people can truly use. And because of that joy, now I can start where I'm going to. I took my slides. I have a standard deck for continuous threat modeling, and I chopped it around so that I could bring the timing down. I had the feeling that we would run over time. And then there's the dread of speaking after Brooke, which is he only had 25 minutes. I have listened to Brooke for hours in conversations, in presentations, in taxi rides to the airport. And I truly believe that you should too. His books have stuff that, seriously, you won't find anywhere else. And I can't wait for the next one coming out, the one that he quoted in his presentation. So with that, now that Brooke set the stage, what is this generic threat modeling process that Brooke talked about? He said, okay, we're going to find stuff and we're going to deal with stuff. But in terms of practicality, how does it happen? You have this opportunity to come to a whiteboard and create your diagram and connect things and say this thing talks to this thing, and this thing goes then and talks to this thing, and that's your system. The moment that you look at that diagram and you say, okay, I recognize each one of the parts, I recognize the way that they talk to each other, I recognize the whole thing, that's a graphic representation of my system with a bunch of information thrown in there. So we have what kind of connection is happening, over which port, is it TCP or UDP, is it HTTPS or HTTP, and so on and so forth. We get this diagram, we annotate it, and we're able to look at the diagram and recognize in it our system and most of its particularities. Now, this is sort of half of the process. We just modeled the system. The second part is, how do you model the threats? And that's where we go to the stuff that Brooke was talking about before. We look at that system that we just modeled with all its attributes, all the things that we know are happening in there. And then we start looking for weak points, much like Brooke. I don't like the terminology flaws, but I try to approach it from a different place. It's not that it's a flaw in the design, it's a flaw in the security of the design. So it helps me cope with as a developer, with people coming and saying that I have flaws. But the important thing here is that once we have those weak points that we sort of identified, look at them, figured out that, yeah, this thing could be done differently, could be done more securely, then what we have is a finding. At the end of the day, the least that we want from threat modeling, the thing that we want to take forward from threat modeling are these findings. This is the goal that we are digging after. It's not enough to have those findings, you have to somehow rank them. Unfortunately, we don't have a good answer to the problem of ranking this stuff. There are some standard accepted methodologies like CVSS, which helps, but does not solve the totality of the problem. But the important thing here is that even if we go with probability times impact and say, this is my risk, and we use that to say, fixing this thing, or rather, completing this thing is more important than completing this thing here, so I'm going to do this one before the other one, that's already a big leg up. Then we get into the stage of collaborating and mitigating. Now, I've seen this explained by other people, and they just jump into mitigate, and it's important for me to put that collaborate in there. Brooke illustrated the loop with the hero threat modeler coming in. I used to call that seagull threat modeling, like the bird, because basically you are sitting, doing your stuff, little birdie comes, flies in, drops a gift to you, and flies away in the horizon, and you have to deal with the gift that was left. So the collaboration here is the place where, in the process of threat modeling, you still have your finger in the cake. You are still there, you are participating in that solution. It's not just enough to go and say, oh, look at the document XYZ and page 13 and do whatever is written in there. Even that mitigation that you brought forward, that's going to change in the process of implementation. So it's important to be there and be part of the process. Then you get to validate. That's the, did we do a good job part of the thing. You have your mitigation, you proposed, you identified something that needed to be completed, something that needed to be made more solid. Now you have to go and poke to see if what you did actually solved the problem. And then you repeat. You repeat modeling the system, and then you repeat modeling the threats. And that's basically the big loop of threat modeling. There are many, 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 many ways. I think that at least 15 were identified, and I'm sure that there are more methodologies of doing threat modeling. So what's the problem? It looks like it's been well-defined, well explored, and 15 methodologies, somebody must be doing something right? The first problem is that developers are not security engineers. So in that collaboration, in that mitigation, and even in the validation, you still need security people. It's one thing for a QA person to say, I test for spec, and for a security engineer to come and say, I test to break the spec. And that's a change in mindset that's not so easy. So security engineers are still needed. And unfortunately, at this point, they are still a rare breed. You also need security experts who are expensive and still rare. So if you could duplicate somebody like Brooke and just put one in every development team, things would be better. They would still not be perfect, because there is still that one expert to n developers, and a lot of things can happen in that in the context switching and in the participation in different pies in that that bakery, and they are expensive. But it's a truth of the world. The market just says that, hey, if you can do this stuff well, you are probably going to be well remunerated for it, or at least more than the average. The third problem is that security changes continuously, both from the point of view of we are constantly creating new stuff. We are connecting old stuff in new ways. We are adding frameworks. We are adding capabilities. And the security aspects of all that stuff changes, and changes continuously. And also from the attacker point of view, these guys are constantly poking at stuff in different ways. They are constantly figuring out new ways of breaking stuff. And it's not much an arms race as it is a sort of a symbiosis. As much as we put bumps in the road before somebody gets to exploitation, they will always figure a way around a bump that we hadn't figured out before. And what we're building changes at all time. And that's where Brooke brought so well, that the implementation changes as the design changes, as the whole thing changes. We are way, at least in most domains, we are way beyond that model where, okay, guys, let's everybody sit down in a room. Let's agree with the design of this thing. These are the blocks. These are how they're going to talk to each other. Now put that in a document, and nobody touches that. That's going to be the thing that we are going to write. That doesn't exist anymore. Nowadays, we have people coming in with a design on a napkin and saying, hey, you know what? This is what eventually I would like to have, something that does this thing here. And then different levels. That person, the CTO, the architect under the CTO, then the chief developer, then the developer, each one of them is going to put their spin on that little thing. And the problems are going to emerge. And each one of them is going to get to a different solution. And then they are going to explore different frameworks, and they're going to explore different stacks and put everything together. So sometimes people try to say, oh, software nowadays is like building Legos. It is. What they fail to consider is that sometimes you are shoeless, and sometimes you just step on the Lego, and that hurts. That hurts a lot. And the thing is that now we have to deal with all these changes. We have abandoned all those waterfall methodologies or all those somebody coming from the mountain with 2 tables describing the system and everybody just going and building the thing. We have to abandon all that. Intermission. So I'm here to talk about continuous threat modeling. That's the methodology. The thing is, I had the opportunity of making this methodology real when I worked at Autodesk. Started about 2 years ago. Now I left, but Autodesk was extremely generous in letting the process be open sourced. So I'm going to point you guys later to GitHub, where you can get all the documentation, the Autodesk threat modeling handbook that describes how the whole thing works. But the important thing here to keep in mind is that CTM is the methodology, and Autodesk continuous threat modeling is an instance, an embodiment of that methodology. I constantly use both names, but I hope it's clear from the context what's what. The samples that I'm presenting here, they come straight from the GitHub repository. Interesting fact, the person who took control of ACTM after I left Autodesk is none other than Alison Schoenfeld, who's Brooke kid. And the apple did not fall far from the tree. He should be a very proud papa. Anyways, so, okay, we got here, continuous threat modeling. I spoke, I said loops and whatnot. What is continuous threat modeling? First one, the methodology says, hey, we are in a point in time. Let's recognize the fact that very rare are the times when you can start working with a project and the project is starting from zero. So let's recognize the fact that there might be something here, it may already exist, and we have to deal with what's in place in whatever form it is. So we start by building a baseline threat model. Now that baseline threat model, from the CTM point of view, use whatever methodology you have that will work in your environment. If you have something that you've been looking at and saying, hey, you know what, that's an interesting methodology, it might work in here, but it's going to be hard to repeat, it's going to be hard to push forward. If that works punctually where you are right then, use that, build your baseline threat model. Now, CTM proposes the use of a list of subjects. And it sounds extremely pretentious, but somebody pointed out to me and I liked it, so I'm running with it. And together with the list of subjects, the Socratic Method. And the reason why that applies, when I show the next slide with the list of subjects, hopefully it's going to be easier to understand. Anyway, keep that in your mind. The second step is, inside the team, name one or more curators. Those curators could be anybody in the team. Basically, what you want is somebody who is extremely serious and that you can trust them with getting a queue of events and basically dealing with each one of the events. These guys are going to be responsible for the threat model and for the findings. Now, have the architects and the developers evaluate each story that they get in terms of security. Herein starts the rub. When we said that the problem with the generic methodology is that developers are not security engineers, architects aren't either. With some luck, you get somebody who is security-minded, so they have a feeling for security. But here we trip on the mine of think like a hacker. Put me in the kitchen, tell me to think like a chef. You can order the pizza because everybody's going to die hungry. I have no clue what to do. I don't know how a chef thinks. I don't know. I wouldn't know the first thing to do. Same thing here. To tell someone think like a hacker is expecting them to have such a huge amount of knowledge beforehand that most probably they won't have. But let's store that for a second. If in their analysis there are no security notable events in that story, continue. Write your story, fix, do whatever you need to do, close the ticket. If there are security notable events, then what the developer or the architect is supposed to do is either fix it and document as a threat that has been mitigated, or they add it to the threat model as an open threat that needs to be addressed. Or if they don't really know what's happening here, but they have that feeling that something needs addressing, then they open a threat finding candidate ticket. Now, I say ticket because, of course, this is based on a queue, and a queue traditionally nowadays uses Bugzilla, Jira, something of that sort. So that's what I refer to when I say ticket. Now, those security notable events, what are they? What's there? Let's just say that there is another checklist that I'm going to show to you guys, and when we get there, I'll explain exactly what they are. Then to close the whole thing, just make sure that the curators keep addressing the findings queue. So they look at those threat finding candidates and they decide what's going to happen. Sometimes it's something that should go into the threat model. Sometimes it's something that's just enough to send it in documentation. Sometimes it's even just talking to the guys at the infrastructure, hey, you need to open another port and a firewall. But the important thing is that those events are noted, they come up, they are addressed, they are examined, they are taken into consideration. The important thing too is that the curators, as they do this work, they make sure that the threat model is always updated with the latest tickets. So here the thing starts taking shape, because basically what you have is a philosophy of threat model every story. Once the developer gets a story in their hands, in their queue, they look at it and they say, oh, okay, so I have to create a new process. Oh, cool, yeah, okay. Two lines, system or exec, whatever, and I have the new process and it's doing what it needs to do. But then we ask them to look at the same request and go back to the beginning and ask what could possibly go wrong, and start imagining those things that, what could be bad in here, right? So let's first take a quick look at the list of subjects. This is the one, this is not the whole list, of course. This is an excerpt of it, but actually the full list is not much bigger than this. I think that by now it has 12 lines or something. But basically it's a subject list, and it has a couple of simple questions under each one of the subjects. And here's where the, quotes, Socratic method comes in. The idea is to have the team look at each subject and start asking questions, and then ask other questions based on the answers for those first ones. And then keep asking questions until everybody's satisfied that they looked at everything. So, for example, can you clearly identify where the levels of trust change in your model? It's a very simple question. And actually, when you diagram, it's very easy to represent that using trust boundaries. But that's already something, doing the trust boundaries might be something already that you would need a security person to do. They have the concept of trust boundaries. They understand what's the meaning of the two sides of a trust boundary. But a team, on the other hand, they can look at levels of trust change in the model. That's something that they can immediately get into it, because they know that in one side they are simple user, but on the other one it might be root or the DBA or whatever. So that kind of analysis and asking yourself, wait, is it important that we have that change? Or perhaps we could do the same thing with both users? It can open up to a series of follow-up questions. And the idea of those follow-up questions is to reach that eureka moment. Well, the idea is that first they answer all the relevant questions, but many times we see them reaching the eureka moment, which is the architect on the top of the table saying, well, this thing has been designed as 1 talks to 2 and 3 talks to 4. And then a developer, a junior developer at the end of the table, raises his hands and says, you know what, we had to change that a bit because of the framework. So they're not exactly talking to each other that way. They're talking some other way. And this is the opportunity when the threat modeling group looks around and says, well, I think that we already got something good out of this thing, right? So the baseline subject list is there just to help build the baseline threat model that starts the whole continuous threat model loop. Now, this is the one that I really like. This is the secure developer checklist, okay? And you could refer to it as the thing that creates security nullable events. Now, this is a completely different list, okay? You guys probably have seen many checklists in your lives, and it's always, did you close the door? Yes or no? Did you lock the door? Yes or no? Did you check that the door was locked 3 times before you turned around and went on your vacation? So you know exactly what you expected to do, and you just check mark each one of them. At the end of the day, you look at the checklist and say, well, I checked everything. Yep, I'm fine. That's the traditional checklist. Now, the secure developer checklist follows a format that's called as if this, then that. The interesting part is that the if this, which is the part in black, has absolutely no security language. There's nothing in the, I think, sorry. If you print the list as it is right now, it's one page front and back. So if you look at the black side, there's nothing in there across the whole list that some developer is going to look at and not recognize. They're always going to say, hey, yeah, you know what? I am actually writing a command interpreter, because there's nothing security there, right? But then on the other side, we start with very simple security. So assume all input is malicious. And here's the point where I take a step back and I go back to a rant that I started in 2008, actually way early, but that rant somehow took me to actually try this thing and see if it worked. And that whole rant is based on Richard Feynman's teach principles and not formulas. If we look at security training, the way that it's been doing mostly today, there are already some vendors changing a lot better now. If you look at the training for security, I like to say that it's like a flashlight that's illuminating in the distance. So you have that point of truth, and it opens up and tries to cover this huge wall. And what you get is this very diffuse light. It's not exactly something that can help you a lot. And it's 8 hours every year of a CBT and somebody just pressing space to get to that one multiple choice question with 4 possible answers. 3 of them are completely unrelated to what we're talking about, and the 4th one is blinking. And as soon as the developer chooses that one, we say, hey, you know what? Now you're secure, you're trained, go away for a year, come back, right? And that's diffuse light in the wall. Now, if you bring things to principles, if you bring things to fundamentals, it's like getting this black card and putting right in front of the flashlight, right? You just found this very, very bright spot in there that's going to eventually lead you to all that stuff in the wall. But right now you have a very, very well-defined bright spot that you can look at. And these are what I'd like to think the principles that I put in this list. So just telling a developer right now, hey, assume that all input is malicious, okay, is one way to make sure that even if one subject that Brooke explores a lot in his books, the security contract between different parts of the system, even if it's well-defined, and you can assume that things are coming well-formed from wherever they're coming from, if something breaks in there by assuming that all the input is malicious, the developer will have an opportunity to think about that security contract again and say, am I enforcing this thing? Is the other guy who's sending me his input, his output, is he enforcing this thing? Okay. Now, as it falls into place, a lot of these principles repeat themselves through the questions. And that's completely by design. So you're going to see assume all input is malicious in 3 or 4 different entries. Now, why is that? Because at the end of the day, the thing that I most want for developers to do with this list is stop using it. And that's why I said, if you print it, it comes into two sides of the same page. I want developers to, at every story, use this list, and at some point say, I already know this stuff, I don't need the list anymore. That's when they build security muscle memory. They stop looking at what they're doing as, okay, I did my stuff, now I'm going to do the security part. And the security part is just part of what they're doing. Now, instead of just blindly accepting a string from the environment, they're going to route it through the library that Chris wrote, and they're going to stop all XSS down the pipeline. So by creating the sensitivity to the security nullable events, by giving developers the chance to develop that security muscle memory, we are basically taking that think like a hacker thing out of the equation, because now they are thinking like secure developers. And the guy in the kill chain who's actually writing the line of code, the guy that actually creates the flaws that we want to go after, stops doing that. So Brooke spoke about the threat modeling manifesto, and I like to think that CTM sort of embodies some, if not all, of the values that we put in the manifesto. And the first one is we prefer a culture of finding and fixing design issues over checkbox compliance. So by making that finding and fixing part of writing it, part of designing it, part of doing it, we are automatically giving it preference than going afterwards and looking for things because we were told to look for things. People and collaboration are valued over processes, methodologies, and tools. Now, this doesn't mean that we can't use process methodologies and tools. CTM itself is a methodology, but it's a methodology that is founded on people collaborating with each other, closing those security contracts, teaching each other, receiving the ticket from one and interpreting for the other. A journey of understanding is valued over a security or a privacy snapshot. By its own nature, continuous threat modeling. CTM says, hey, it goes on and on and on and on. We start here, we end there today. So it's not a one thing, and it's not just looking at security or privacy. Very important, doing threat modeling is so much more valued over talking about it. And believe me, I'm somebody who's been talking about it for a long time, but I still enjoy more doing it, because doing it gives me more ideas to talk about it, okay? It's been, I don't know, what, 10 or so years since I actually started heavily focusing on threat modeling. And I did it with a huge amount of teams. And every team taught me something else that I could take into the methodology that I was using, or the way that I did threat model, and made it better. And at the end, continuous is continuous. So continuous refinement over a single delivery. We have to understand that when you have continuous refinement, when you are doing threat modeling, when you have a culture of finding and fixing design issues, when you understand that it's about the people and the way that they collaborate, and when you put all of these together in a journey of understanding, then almost automatically, and I know that it's a huge claim, but almost automatically, you're going to get to a culture that is blameless. So when mistakes appear, they are looked at as mistakes and not as somebody did something bad. And a culture of psychological safety where people can step up and say, hey, there's something here that perhaps we should analyze, we should look differently, perhaps we should do it differently. And at the end of the day, continuous threat modeling comes to say, hey, you know what? It's okay not to be perfect. It's evolutionary. The important thing is that tomorrow you suck less than you sucked yesterday. If you found one thing between today and tomorrow, it's already one more thing that you had before. Okay? You can't describe a methodology or anything else and not say, hey, this is what we observed when we tried to use it. So the first one was, what? A lot of people just looked at it and they could not grasp it. What is it that you're asking me to do? How come you're asking me to, what? And I found that comes, I had the luck to work with global teams. And I think that I can safely pinpoint that to being a sort of a culture thing. You have teams that are more independent, teams that are a bit more willing to accept a more formal way of doing things. And the way that they would approach CTM depends a lot on that. There are those people that look at that and say, hey, this is heavy and it's going to make my development cycle slower. And you know what? They're right. Right out of the gate, they are right. When the developers are building that muscle memory, they're right. They're going to be slower. I'm asking them to do something that they didn't do yesterday. So of course they're going to be slower. But as they progress and as they get sensitive to the security notable events, as they build that muscle memory, they're going to move faster. So basically, at the end of the day, if usually you had development and security, at some point you're going to pass security in front of development, because now they're going to start thinking of security before they start writing. And then at the end of the day, security comes as part of the development, and that time goes back to what it was before. Not to mention that, yes, it's going to be a bit slower in the beginning, but you're going to save time in the end. And that time is not only costly, but it's going to be time as an emergency. Time as everybody stop everything and go fix that thing because we didn't get it at design time, if you even can. When will I know I captured everything? You won't. You simply won't. There will always be the feeling that, oh, I forgot something. And you know what? That's a good feeling to have. Because first, it means that you are getting there. You're getting into the mindset of the thing. And second, it means that you care. And to do all this stuff and not care, it's simply undoable. You have to care about this. But the important thing is to know, again, it's evolutionary. Perhaps you didn't catch everything today, but tomorrow you catch something else and you're going to learn a new trick. You're going to learn a new attack vector. You're going to learn a new attack tree. And then you're going to think, oh, wait, this applies to my system. You're going to go back and you're going to find that thing. And finally, I had never seen a room of architects excited about threat modeling. And that was in a meeting of only architects, where basically people came to say, no, we cannot threat model because A, B, C, D, and F. And they came out saying, yeah, we can try this. It looks like something that we might make work. And actually it did. Numerically, we had this interesting case where an application that did not know anything about CMT, did not know that we even had a methodology to support them. They just found this tool floating in the network. They took it on, did all they had to do, and they came up with 357 items. And they were mostly false positives. Whomever is familiar with the really, really good and really, really pioneering tool that is TMT, will know that it has a number of drawbacks, especially if what you're modeling is not a Windows system. And it does tend to create a bit of noise. But then the same team adopted CTM, and over the same system, they applied it, and they came up with 13 findings. All of them were highs or criticals. So the system has been proven in the field. It's not perfect. There are some things that will continue to be broken and some things that need to be taken care of. So the first one, and I think that I commented that at the time, is that the list of subjects. You have to get people talking about that stuff. You have to get them discussing that stuff. Some teams just looked at it and went, yes, 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 no, yes, yes, no, 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 yes, yes. Baseline done. And to convince them otherwise that, no, you need to have a heavy discussion about this stuff was hard. The model that results, again, it's not complete. You have to come at it in terms of an evolutionary approach. You have to know that, yeah, there will be things that need to be revisited from time to time. So probably it won't be complete the first time. If the teams are extremely young, extremely unprepared even to answer the baseline questions, or even if you want to foster that initial discussion, it helps a lot to have somebody who knows security around. Now, the difference now is that that security person is not responsible for every aspect of security in the teams. They are there to foster the discussion, to foster the mindset. And very important, garbage in, garbage out. You only get from the methodology what you are ready to put in it. I wanted to sneak some words about PyTM. PyTM is the tool that Brooke brought up in the beginning. I don't think we have time for any kind of demo or anything, but it's an attempt at threat modeling as code. It uses object-oriented syntax to express elements and their attributes. So the things that you saw in the diagram there in the beginning, we try to say, oh, it's a server, and that server is using HTTPS. Right now, it can create DFDs, sequence diagrams, and do that in a multi-level way. So you can express the same system in one file, but only look at specific parts of it. There is a templating language to create reports. Those reports come out in anything that's ASCII, basically. And you can translate between them with something like pandoc. Right at this time, it has 101 threat rules that come from OWASP Top 10, from KPEC, from Attack. And it tries, this is where I tie, why am I talking about this tool at all? This is where I try to tie things together. We have found it supporting CTM because since it expresses the model as code, it lives together with the code that it is actually representing. So you can put it under version control, you can share with other people. It's not operating system dependent. So it does give a lot of flexibility to that dialogue that needs to happen around continuous threat modeling, around the items of continuous threat modeling. important to say, exactly as Brooke pointed out, it looks for low-hanging fruit. The importance here, to me at least, of the tool is not that it's trying to find things that you wouldn't find yourself. It's just trying to take some work out of your hands. But more important than that, in my view, it's facilitating the way that you are building that common view of the system that everybody can agree, yes, that is the system that we are trying to model. And it's trying to expose those places where somebody has to go and look at a bit closer. So this is what I had. Some references here. You can find Brooke and myself at Twitter. We also hang at the OWASP Slack on the threat modeling channel. Both of us have some presentations, and Brooke has many others, from EPSA California, 18, 19, and 20, where we focus on stuff that we discussed today to a more in-depth. The Autodesk CTM can be found on GitHub. PyTM can be found on GitHub. Secrets of a Cybersecurity Architect, which Brooke, I haven't seen the new one, but to me, it's one of your best works. I think that everybody should actually really go and have a read on that one, not just for the technical side of things, but for the opportunity to look inside the head of someone who has been doing this well for so long. And the thing that Matthew Coles and I put together, the Threat Modeling Practical Guide for Development Teams, where we look at some of the methodologies that are out there. We look at CTM, we look at PyTM, and we explore it in a way that we hope that developers and architects can readily use this stuff.
Can I put a plug in for your book, Isar? It's got a comparison of the major threat modeling, not just a comparison, but how useful and what else you have to do. An entire chapter is taken up with that. That one thing is worth the price of the book, because that isn't anywhere else where you can really look and say, okay, what does Pasta bring me, or what does Stride bring me, and what does it not bring me? That one thing. Besides the fact that it's a very thorough. If you buy no other book, buy this book, but because it's a very thorough, description of what threat modeling is and how to do it. But that one part, nobody's got that. You won't find that on Wikipedia. You won't find it anywhere. So let me give a real plug for Isar and Matt's book, because it's a unique. The thing is, there are only 4 extant books on threat modeling.
True.
Let's be really clear. Isar and Matt's book. Adams is the Bible, if you will. Really. Frank Swiderski's book is now fairly deprecated. It may be worthwhile. And there's my book, Securing Systems. There aren't that many. So, if I was going to build a library, and then there's the Pasta book, which is an interesting, a lot of stuff about risk, which is good. So, that's it.
But it has to be said that Securing Systems, I think that's the value there is not only as a threat modeling book, but it also shows you the right thing to do. It shows you the many things that could go wrong, but it also says, this is a system, this is a template for a system that does banking in the cloud. And here are the things that you really should look at. So there is both Adam's book and yours, I think that the fact that they focus on the right design, that brings a lot of value to that.
Oh, thank you.
Mm-hmm.
That was the attempt. So we
and also the fact, and what I remember also from Brooke's book is the credible attack vector aspect or concept in there is a really good one.
True.
Because we see a lot of what if, and Hollywood scenarios from developers thinking how their software can be hacked.
Yeah.
And I said, let's start with the basics first. Indeed.
Yeah, well, there's something about that. I think the moment when you're threat modeling and you start to go into an imagining attack or technologies or attacks that haven't yet ever been done and require stuff that nobody knows how to do, you're done for the moment.
Yeah.
That's a good moment to know what the definition of done is. You've gotten everything that you know about, and now you're starting to make stuff up that's a time to stop, really.
But
Unless you're
there's-
doing, unless you're doing like major nation state stuff and you got to do that. But for, us mere mortals, probably you can stop there.
But there's also the other side of that, Brooke, that we discussed at the Threat Modeling Manifesto, that sometimes people get looking at, they start looking too much at the shiny stuff, and they forget to look at the low-hanging fruit, or the basic stuff, the dumb stuff. Yeah. And you end up with those glaring holes in one side, and everybody fascinated about the side channel
yeah, that
attacks.
just happened to me. That just happened to me. I was volunteering on one of the exposure notification open source projects for security, and generalized threat model, and that allowed me to be able to do it visually, and also I didn't have to do the basics. It was all right there, all the different components, and I just stuck on all the mitigations and a couple of threats that I thought they'd missed, and I gave it to them and I said, here's your threat model. And immediately somebody came back and said, yeah, but what about all the details down here in the protocol, which we had thought about, by the way, deeply. But I'm like, yeah, if you forget if you put your admin passwords, or their admin, ADMIN, of your deploy system, the attacker doesn't care about that protocol. They already own your stuff. Do the dumb stuff first. And I actually did post about that. Do the dumb stuff first, because that's where the attackers are going to get you first. It's going to take them a while for the protocol.
Definitely. All right. So we have a couple of questions coming in here while I'm just checking also with Edwin to make sure. Are you sharing, Edwin, the speaker view on the YouTube live stream? Because I'm now seeing the logo.
Oh, yeah, I stopped sharing.
Okay, yeah, that's fine. Just making sure.
Speaker view will be up in a couple of seconds again.
Okay, great, thanks. All right. So in the meantime, I have a couple of people on our live stream that are asking some questions. One of the questions from Aram I wanted to share with you is, when will threat modeling become mainstream? And there's a follow-up question: when will we convince the industry to stop asking for checkbook compliance and start asking, show us your threat model?
Great question. We're working hard at this. I'm just going to say I've spent the last 12 years of my life trying to make this mainstream, and obviously I'm a failure. Obviously I am an abject failure because we're not there yet. Do you know the first standard that I could find, and it may not be the first standard I could find is NIST 814, 1996, says get your security requirements early in development. And that's basically what it says. 1996, and here we are, 24 years later, almost 25 years later, and we're still asking this question. So got any ideas, Isar? Help me out.
Yeah, I think that I have to take the easy way out and say, apart from standards and all that good work that came before, this thing is not going to become mainstream until we stop looking at it as dark magic. And until we start looking at security as another facet of quality. Because when you're interviewing a new developer for a job, you're going to ask them, hey, how do you write this loop with one or whatever, or memory requirements? But you never ask them about security, because you want your code to be performing, but you're not really interested if it has to be secure code. So until we go over that bump and say, hey, it's as important for me that my developers know security as they know performance, we're not getting anywhere. Because again, at the line of code where things actually happen, has anybody ever heard of NIST whatever?
It's also got to do, and this is also a little bit of a question I prepared for you, Brooke and Isar. I still regard threat modeling as a craftsmanship, like Brooke in the beginning, just before the call, we had we discussed it a little bit because of a master's explaining it to people, and hopefully they'll get it. What would be this not the single, but what would be the most important thing to do for us as a community to bring it somewhere near, I would say, a engineering practice compared with other fields of practice?
Well, I want to say there's a couple of things here, and there are a couple of different threads. But first, as we said in the threat modeling manifesto, just do it. And stop worrying. We those of us who are security people have to stop worrying about, well, you're only going to find 2 things, so no, you can't do it. And it's super secret. Well, we trust people with the code. And this is an almost direct quote from my friend James Ransom, but we trust people with the code, and they're doing the code reviews and whatever. If they have the code, they can handle the secrets of a threat model, believe me, because they could stick a backdoor in there, and slip it through code review if they wanted to. And I have actually seen that happen. So, if you trust them with the code, and we have to remind each other that, yeah, it's sensitive, but my experience with thousands of developers, I mean, at one organization, tens of thousands of developers, is when you remind them that it's sensitive, they will go, yeah, right, thanks for reminding me. So, we have to remember, just do it. And as Isar said, you come up with 1, right? Great, that's better than you were yesterday. If you come up with 13, fantastic, birthday very much, then you're 13 times better than you were yesterday. Great. So maybe somebody who was a really deep practitioner would have come up with 14 and a half. I don't know. But, that's a pretty good result. So first, we got to let go of that, 80-20 rule that says, and this super secret black magic, as you said, Isar. But the other side of it, and this is a place where I think we've been weak, and we're trying to address this with the manifesto, is if we're going to make it a practice, we have to define it. And I said that in my presentation, and I really believe that. One of the threat modeling manifesto folks had sent me an email this morning that said, yeah, you seem to do some formal stuff, Brooke. And I do formal stuff to establish a discipline. I don't it informs what I do on the ground, which is, use whatever works. Creativity, adaptability, these are all important as well. But if we're going to have a discipline, we have to tell people what it is. And that's where the formality happens. It's not about saying, only do it my way. There isn't one way. I have seen people threat model from every single angle and come up with great threat models. So I am convinced there is no perfect way. There is what way works for you, because there's a piece of you in this that's creative. But if we're going to form a discipline, then we have to at least have formal definitions that say this is what it is. So there's a place for each. Isar, any?
Yeah. I think that we have referred a lot to the threat model, and if it's okay with you guys, I would like to share the screen again and just put it there.
Please.
Because I think that's part of the answer to this question lies in a bunch of stuff that we put in here. So in the threat modeling manifesto, we try to answer these questions 5 or 6. So what's threat modeling? Why? Who should do it? How should they use the manifesto itself? And here we start. We have the values that I presented in my presentation, and I showed how I think they connect to CTM. But then we have the principles. And in the principles, which are the things that we follow when we are doing it, okay? And here we start to answer this question, which just go back, how do we make this thing less of a black art and more of a discipline? But then we get to the patterns, but then we get to the anti-patterns, the things that we have to stop doing. And I think that here starts the real disciplining of the thing. Like, we were a team of 15, 16, Brooke? And we had people from academy, we had people from industry, we had practitioners, we had people who write about this stuff and talk about this stuff, so meta threat modelers. And it was very important for us we had a very long discussion around this, how do we make this thing a discipline? The hero threat modeler was one of the big obstacles that we saw, because that's the guy that comes in with the t-shirt saying, I threat model. And he's the only one who's going to touch the threat model, and he's going to be the seagull that's going to leave the gift and go away. And nobody else threats model. Why? Because Izar is the guy that threats model. But I think that I talk to Izar. But I think that we can talk to Izar. And we have to stop that. We have to say everybody threats model all the time, because it's what actually we do, right? Perhaps at different levels of proficiency, perhaps at different levels of focus, but we all threat model one way or another all the time. The other thing is the admiration for the problem. Sometimes we look at the problem of threat modeling with such big eyes, perhaps going back to the hero threat modeler and saying, oh, there's only these 5 people in the world who are enabled to do a proper threat model. And we don't try it ourselves. Try, fail, try again, understand where you failed, get better tomorrow. If you don't try, you don't learn it. The tendency to overfocus that Brooke touched on before. Don't look at the small piece of the puzzle in here and spend all your time looking just there. If you're not having success there, look at the rest. See what you can learn of other parts, right? And the perfect representation. There will never be a way to represent a system as good as the code of that system. That's the only perfect representation of the system. Everything else is going to fail in some other form. So don't try to go for perfect. Try to go for good enough, for something that expresses what you're trying to model, something that lets you see the aspects of the thing that you're trying to model. So once you overcome these 4 anti-patterns, I think, you're on your way to start saying, okay, this is the way that I threat model. And then the next step is, this is the way that I threat model that works for this specific place or team or project or whatever. And that's when you start finding your own principles, your own values, and developing your own methodology, the thing that works for you. And at that point, it's not dark magic anymore.
Can I tag on one thing that Isar said that I think is really important? And it has to do with the perfect representation. You don't have to know about architecture or be an architect to threat model. You do not. And in fact, I believe most of us threat model in our daily lives anyway. We think about, going on the icy road this evening is going to be risky. Maybe I don't actually need that bottle of vodka as bad as I thought I did, or whatever. Maybe you live in a state where it's legal to have pot and you don't need that baggie of pot as bad as you thought. I don't know. I'm just making a joke, right? But we all threat model to some extent anyway. But I will say that the art of architecture, which is as old as the pyramids, at least those are the first architectural drawings we have, probably older, but at least as old as the major pyramids. We have those architects' drawings. We know that they were doing architecture because we have their drawings and we have their writing about those drawings. This is not a question. This is not a guess. We know. So, the moment you have anything that's too complex to hold in your head, you start to draw its structures and you start to obscure detail. And that's why there's no perfect view, because each view is a representation. It's an abstraction of something you want to examine while removing other detail that just gets in the way. Have you ever seen one of those architectural drawings where they tried to get everything on the same page? Oh my gosh, it's like the eye chart. It's awful. It's impossible. And all blessings to the people who try to do this, but it's just impossible. My eyes glaze over. And so what we do with architecture is we're trying to say, okay, these I think are structural elements we're interested in, which is why when you're looking at the network map, it's a vastly different drawing than the hosting map, than the cloud map, then the general system architecture, then the enterprise architecture, then the functional. These are all, and so the one thing I would say to people is if you want to get better at this, go look at what enterprise architects have written and talked about, because they actually have a discipline. And I have learned more from enterprise architects to be a better architect. I was an architect when I got into security, just by happenstance of my long development career. But nevertheless, they refined my architecture to where I feel like I'm a practitioner today because they have written a lot and a lot of great books, a lot of great writing. So if you're more interested in it and you want to become a better designer, go read about enterprise architecture, because there's a lot there. It's a real discipline. Just wanted to put that plug out.
That's great advice. Now, we're nearly towards the end in terms of time. I will still have tons of questions, but I'll pick one question which is interesting from the chat. And it's interesting because we focus a lot on the threat modeling as an activity itself. But the question from Javon is, any recommendations for frameworks that are suitable to communicate threats to business stakeholders? So APEC or Stride might be too technical, but how do you explain the outcome of a threat model to a business stakeholder?
And the wrong thing to say is it's a cross-site scripting and you get it by putting scripting tags in your HTML. That's the wrong thing to say. And it's bad. That is the wrong thing to say, because any executive who understands that and wants to get into those details isn't doing their job. I'll just tell you, because that's not their job. That's our job, in my opinion. It's a very strong opinion. But, I have not seen that thing. I have not seen that resource. So maybe Isar has it, but I have not seen the resource. And that's always been my job, and to teach. And I've, this is not a brag. I've taught hundreds of security architects by now in my career. And so, that's one of the things we struggle with and a lot is to up-level that into what. So a way to think about this is, what's the negative impact in business terms? And that's usually what will get the decision maker to understand whether they can take that risk or not. And that's not my decision. Hopefully, I don't want to make those decisions, but nevertheless, that seems to get it. So let me say, in my practice, I say, think about the business thing. And if I go back to a cross-site scripting, your customers are being hurt by attackers. Our servers are not being hurt at all. None of our code is being hurt. It's being abused as a vector of attack. But our customers, so if you don't care about your customers, great. Let them get whacked by cross-site scripting. If you do care about your customers, then maybe it's a problem, right? And that's business terms. You see how I've up-leveled from cross-site scripting as scripting tags to what it does to our business. If I'm going to see my customers multiple times, I don't want them to be hurt by my website.
Right. And I think that together with that, the way that I distill the whole thing is to say, it's always a business case at different levels. So if I'm presenting risk to the developer that's going to fix it, I'm going to present that risk as your input is being codified in a different way and you're getting an XSS the other way. If I'm doing that to the executive, then it's going to be in terms of your brand is going to get a hit because people will know that your site doesn't protect itself well. And to each one of them, that has a value. To the developer, it has a value in hours. How much more work it's going to be for them? To the product manager, how much that's going to push my delivery? And to the executive, it's going to be millions of dollars. So finding that word, that vocabulary that applies to each one of the different levels of business cases, like look at the term business cases more as the idea of presenting something in a way that's interesting to the person that you're talking to, and less like business. And that's the secret. Now, just as a parenthesis, there is a new threat modeling tool that appeared lately called Agile by Christian Schneider, I think is his name. I'm so sorry if I'm getting the wrong name. But one of the good things about the tool is that it does a lot of what the other ones do. It's also a threat modeling as code starting from IAML, but they have what I think I have seen as one of the most complete ways of generating a report and presenting that risk. It's standardized. I believe it's flexible. I haven't played with it yet, but I remember distinctly that was the first idea that I had when I saw the first report that I generated. My God, this is something that I can hand out to an executive, and they are going to understand it. Okay, so again, I think it's but I think it's a clear case of translation. going from level to level, improving that business case, translating it to the next level.
So I'm going to put a plug in here for FAIR, Factor Analysis of Information Risk,
Right.
which is
Yeah.
all the risk methodologies that I use are based on FAIR. I'll just let you know. But his book, Jack Jones's book, and he's the guy who invented FAIR, goes into how you translate into potential loss events. And using that term, he doesn't even like risk, because can we calculate risk in information security? Not yet. We don't have actuarial tables. So that's real hard. And CVSS doesn't get it. It's as you said, it's a piece of the puzzle, but don't rely on it by itself. And there are a lot of reasons. I've written a lot about this. Go look at that stuff. But nevertheless, look at FAIR, because in that book, he describes how you get to that kind of terminology, a business case, as opposed to the technical piece. And I'll throw in another thing, potential book writers. There's a book here.
There is a big book here.
There is a big book here, yes. All right. Well, with that, I think, unfortunately, we're at the end of our session. Isar, Brooke, thank you very much for joining us.
Thank you.
Hopefully, in the future, we'll be able to see each other in real time, in real life again. Until then, we'll see each other online. So thanks for your participations, and see you soon.
Thank you.
Thank you very much for inviting me.
Oh, and anybody with more questions, again, we are in the OWASP Slack channel. So drop by and
Yeah, hit us.
Yeah,
Hit us up,
definitely.
please. Yes. Other questions. Or hit us up on Twitter and a direct message. My direct messages are open. That means I get trolled all the time. I fill those out.
Same here.
Okay.
Awesome. Thank you, guys.
Gentlemen, thank you very much. Enjoy your day. Okay. Edwin?
Yep, thank you. Thank you all for watching the show. I've switched, as you can see, to the end presentation screen. There are 2 more days left here on the conference, and the topics can be found on OWASPBeNeLux.eu. If you haven't read them already, there are multiple talks coming up, and those involve... Wait a second, once I see my browser. Yeah. These involve, tomorrow, we have the OWASP project tour with Nicole Becher and Nancy Gariche from OWASP Desktop and Grant Angers from OWASP Cornucopia. If you're looking for the presentation of Jeff Foley, and you perhaps registered before the weekend, please note that it has been moved to Thursday and it is now our closing node. So on Thursday we have Anastasia Voitova on maintaining a crypto library and Jeff Foley on OWASP AMAS. Again, they can be found on YouTube, and the details for those channels can be found on OWASPBeNeLux.eu. We hope to see you all again tomorrow. Thank you for watching.